branch. First, let me switch to branch -a. Git switch. Let remote -b. So just give me a moment. Let me see the Java fundamental that I have created so that I will do the needful. Okay, so Java fundamentals. Git branch -m DSA fundamentals, or suppose. So when I say DSA fundamentals, for suppose where is the branch is. So in this SRC, let me clear up all the stuff. This framework. Let me clean up all this stuff. So this is the first attempt we are doing it, guys. I hope we all will be successful with your continuous support. Let's see how it is useful for both of us. Yeah. Okay. So before we get started, I hope everyone knows what is an array, right? Yeah. I know everyone knows what's an array.
Yes.
So what's an array? Can anyone tell me? What's an array, guys? Can anyone tell me?
Continuously storing similar kind of data.
Okay, continuously storing similar kind of data. Great. So when you say continuously storing similar kind of data, what will happen here? So continuously storing similar kind of data. Just give me a moment. Excuse me a moment, please. Okay. So we have understood what is an array. Array is like a collection of homogeneous set of data and all. So let me create a package. Since this is the first class, it'll be a tad slow, but don't worry. Next session onwards, we will catch up quickly. So we know what is an array. So let's try to understand the search algorithms. Search algorithms in an array. So what are the different search algorithms that we have? So let's understand the linear search. Okay. So let's put the things onto the blackboard and let's try to understand. Have anyone has heard of the linear search in arrays? Linear search of searching the values in the arrays. Now consider this is an array. Okay. Now this is an array. This is an array. Now this is one block of data, right? Okay. Now this is a block of data where I have the values like 20, 40, minus 21. Okay. We have 5 values in the array. Okay. Minus 4, minus 32. And I have the value like 60. And then have the value like and I have the value like 100, right? Now, what is the value you want to search? Now, what is the value to be searched? Value to be searched, I'm searching for the value called as minus 32. When I want to say search for the value minus 32, how will you do it, guys? First, what will you do? You will check whether this value 32 is matching with this minus 20 or not. Not satisfied, right? It's not satisfied. Now, again, I'll check whether the minus 32 is matching with this 40 or not. Not satisfied. Now, next, what I will do? I will check whether this minus 32 is not satisfying this condition. Right. It is satisfying. So what it will do? What is the index position in this case? It returns the index position as clear. Clear, everyone? What do you mean by this linear search, guys? Now, in an array, there are some list of values. Now, what is the value I'm trying to search? I'm trying to search the value that is minus 32. When I say I'm searching for the value minus 32, what I'm doing here, I'm checking whether this value is matching at the 0th index position, at the first index position, at the second index position. Got it? Got it, everyone?
Yeah.
The value is matching, it returns the index position. Perfect. I hope everyone is clear.
Yeah.
Any doubts so far?
No.
Right? Any doubts so far, guys? All good?
Yes, Raghu.
No, no.
So, if everyone understood this thing, can we see this thing programmatically? Can we see this thing programmatically, how it's turning out?
Okay.
Now, let's take an array. I'll say int a equal to, I'll just declare some values. Now, what is the value I want to search? Int key equal to some 50, right? Int key value equal to 50. Now, let us try to create a method here. Okay. What is the method I'll create? I'll say public static void search public void linear search. And I say public static void linear search. So what I'll do, I will pass this array. I will pass this array and int key. Now what I will do, I'll have to run a for loop for int I equal to 0. What is the length of the array? Got it? Now what I will do, I will check if that particular value of I is equal to key or not. If this value of I is equal to key, then what will happen here? What will happen here? Then what I will do, I will say value is found at index. Got it? Once I found my expected value, then I'll break the code. Clear?
Yes.
So let's call this method. What is this method? Linear search. Okay. Now once I call this method, so what will be the output here? What will be the output? Can anyone tell me?
It is not there. So
Yeah, it is not.
Element not found, kind of. I don't know. Some error.
So it will print an empty value. I've not thrown any error, right? If the value is
Okay.
found, only it will print. If it is not found, it will throw an error.
Okay.
Okay. Now here, instead of this, if I pass 32, what will be the output?
same error.
Okay, I'm not throwing any error.
Invalid key.
1.
Yeah.
Got it? So, what is the problem with this linear search? Now, everyone understood the linear search algorithm, everyone? Naresh,
Yes.
any doubts so far?
Yeah, I have doubts, Rahul.
Yeah, tell me.
Like why we are using DSA?
Sorry?
Why we are using DSA?
Why we are using DSA is because this is only for interview sake, and at the sometimes when you are asked to design something, they will check how well are your analytical skills. Like tomorrow, if I give a problem to you, how will you approach it? You go for any big product-based companies, and you go for all these companies, they'll ask, how do you solve this question, especially with arrays. They'll give you a question on arrays and they'll say like, okay, this is the array that I have in your hand. How do you solve it? Like tomorrow, if I ask you to find the sum of distinct integers, find the sum of values which has distinct integers in an array. So how will you solve it? So they'll check your logical abilities and all. Most likely we use it only for the interview sake and coding competitions only. Apart from that, we don't use it much in real time. In real time, we need to know the design patterns. We need to understand the design processes and all those things.
Yes, like it is mostly used in array basis,
In arrays
mostly
will be
used in
there,
array.
in list also will be there. Tomorrow there is a lot of algorithms like greedy algorithm, graph algorithms. They will be testing your logical and aptitude skills. So some companies, when you want to go for a better pay, na, like a product-based companies, like there's one company I don't want to name it, but they had 6 rounds of interviews for automation testing in the recent times. So they are hunting for a proper estate profile, which they couldn't get it for past 3 years. There are some companies like that where they test you with your core Java skills. So you have learned a lot of data structures, right, during the regular classes of Java, like arrays, list, collection. You have seen it from an automation perspective, but if you want to see from a coding perspective, this is what is required. Data structures is a very important subject for any age of coding, any experience of coding, any level of coding. So if you start attending
Okay.
interviews, you'll understand, Janvi, more and more. Like, since most of the people already knew, that is the reason I didn't introduce that way. But anyways, since you asked it, I've given you the exact reason.
Okay.
I hope Janvi, I'm
Thank
okay.
you.
You're clear. So for people who are trying to switch jobs, if you're not trying to able to crack an automation for the XYZ reasons, you can also apply for SDET sometimes. Maybe you might be good in Java, but somewhere you're stuck in Selenium. So these DSA kind of questions, if you're able to solve, you can get a better pay also, because the current trend that everyone focuses is the programming language. How good are in your programming language? Okay.
Rahul, I have a very silly question. Like, I was trying to read this. So, what is the difference between like DSA and algorithm? Like,
DSA is a DS stands for data structures. Algorithm means what kind of a logic you will have. Now, right now, I've written the code in Java. When someone
mm,
asks you to write the pseudocode, you have to write the pseudocode like this. Like they want to test your logical skills. Now, I have this function array. In this array, I am passing an I'm asking in this function linear search.
yeah,
I'll pass some array, some key. I'm just writing my logic. Am I using any programming language here?
no.
For I in array, that means I'm reading an individual value in array.
Mm-hmm.
I want to check if that individual value is matching with the key. If it is matching, then print key is found like this. Okay.
Yeah,
This is not like your exact code, but this is the algorithm. They will check like how we are approaching to the solution. Always the companies look out for what kind of approaches you follow in your coding pattern. It can be for automation or something. Tomorrow, if they give you a if situation, how do you write the code? They don't expect you to write a Java code at first. They want you to understand, okay, this is the thing. How do you link up the things? How do you design the things? Because they're expecting you to know what kind of a strategy you're thinking. That is where
yeah,
algorithms come into picture.
okay.
So for the people who are having less than 3 years of experience, they might not understand this clearly. Okay, they might not understand the gist of it clearly, but people who are having more than 4 years of experience, they'll understand what I'm talking about.
Mm-hmm.
Like we have Kartika, Chiranjeevi is also there, Madhavi, Shalu, who are in the industry for more than 4 years, they'll understand these things clearly. What is the necessity of it? Why am I talking all this? Right?
Yeah.
Yeah, Revati, Kartika, clear? So this is the pseudocode that we write. Pseudocode means it's just like a, not like a programmatical way, but something in a linear way, like it's a function I'm writing. I call this function. Inside this, I'm just checking what is there, I'll print it. Does it have any programming language? Kartika,
No,
Shanu,
no.
Revati. No programming language, nothing is there. It's just pure thought process. So like this, we have to design the algorithms. Okay. Clear? Any doubts so far?
Clear.
I hope if everyone is clear, can we go over the next one?
Yes.
Yes, Rahul.
Okay. Now, once everyone is clear with it, let's go over the next one. Okay. Now, let us see what is the drawback with the linear search. The drawback with linear searches that we have to iterate across the whole array in a worst case scenario. Have to iterate across the whole array. Like, for suppose if the value is found at the first index position, that's great. But if the value is present at the last index position, then I have to scan through the whole array, right?
Yeah.
The best case scenario in the interview for any algorithm, the commonly asked question is, like you're saying that this is your design. What is the best case scenario of it? That means what? What is the best case? What's the worst case? Like in which scenario, how much time does it take? Like in a best case scenario, how much time does it take? O of 1. That means what? If the value is present at the first index position. So ultimately, whatever algorithm that we design, whatever design that we showcase and explain, the whole point that they'll ask is, okay, you have written some code, some logic, that's fine. How much time does it take to execute in a best case scenario? How much time does it take to execute if it's in a worst case scenario? Like you have a test case. Now I put it in automation. This is one of my best case scenario or a happy flow, and this is my complicated scenario. And this is my medium level complexity. So if I do like this, how much time does your framework take to process this data? Process the scenario. Suppose if the elements load quickly, how much time you take? If the elements take some time to load, what is the worst case that it will take to load? Take to execute the case via automation. Clear? Any design you do, these are the common questions you will be asked. And you need to be ready to answer all your questions. Clear? So here, this big O, whatever we discussed, represents the notation to determine the time and the space complexity. When I say time complexity, here we mention how much time does the algorithm take to execute. Space complexity means here we mention how much memory is required to execute the algorithm. So as automation architects, if you want to become, these are the two big criteria that you need to look at it. Like if you're executing some algorithm, if it is leading to memory leakages, then your algorithm, then your design, what you're doing is not fair. If you are writing a code which is taking more than the usual time, then that is a problem. I hope everyone is clear with it. I hope
Yes.
everyone of you are able to correlate with the Selenium task that we are discussing.
Yeah.
Yes.
So at the end of the day, no matter how much of our automation, how much of our algorithms you bring into picture, now tomorrow if someone asks you to search for a data in a tabular form, and most of us we do a linear search like this, then it's a problem. That's a very big problem because I'm not in a mood to scan across the complete array and check whether it is there or not. Got it? So most of us, 99.99% of automation engineers go for a linear search of a mechanism. Got it? Any doubts so far, guys?
No.
What others?
Good, Rahul.
If everyone is good, can we go to the next one?
Oh, okay, Rahul.
Okay. So let's discuss about the time complexity. Here, space is not a big issue because it consumes the same amount of space. What is in the time complexity? What is the best case scenario of one? That means if the value is present in the first index position, that is the best case scenario. What is the worst case scenario? O of n. What do you mean by O of n? Time taken to execute the algorithm increases as the size of the data increases. So that means what? If the size of the data increases, then the time taken to execute the code also increase. Clear? Is this clear, guys? Any doubts so far?
No doubt.
How about others? This big O is the notation that we use because tomorrow if I have 10 values, I cannot write O of 10. Tomorrow if I have 15 values, I cannot write O of 15. So we use the value n. Like in the worst case, if the value of n is equal to 10, then I'll have to go iterate across 10 times. Then it's 15, 15 times, 20, 20 times. So it's a representation of saying that, okay, how many values are present in the array, those many times I have to iterate. So that is why we say O of n. Okay. There are different notations like this big O notations, which I don't want to explain everything right at the start. With the help of algorithm, if I explain, then you'll remember all these notations. O of 1 means it's like present at the first index position. It doesn't take much time. It's like a constant time. Got it? Got it, guys?
Yeah.
Any doubts in any terminologies? Because this is the first session. Many people have many doubts of why do we need this or what do we need this. I hope I've answered that question, everyone. Why do we need this? What if we don't have? Yeah. Is this clear, everyone?
Yes.
If everyone is clear, we'll go for the next one. Okay, this is the problem with the linear search. Now, let's go for a concept of binary search. In any of the DSA things, now we don't go for any advanced functions like streams or something like that. We just go with the basic fundamentals of Java, like a for loop or something like that. So, what did we discuss is linear search algorithm for arrays. Okay, this is like a linear search. Now let's understand what is a binary search. Okay, let me take the same set of 5 values. Okay, Let me take the same array. Okay, I hope you got the same array here. Now let's take the same array. Now let's understand binary search. This is one of the most tricky algorithms where it follows under the concept of divide and rule. Okay, it follows the concept of divide and rule that we'll discuss later. What is divide and rule? Now, if you see here, let me take this as a starting index position. Starting index position. So we call this as the leftmost value. And let me take this as the end index position. What is this end index position? As the rightmost value. What is the middle value here? Minus 32 is the middle value. Yes or no? Yes or no, guys?
Yes.
So this is my middle value. Now, what is the key value to be searched? What is the value to be searched? I will say I want to search for value equal to 60, right? So value equal to 60. What we did, we have used the linear approach. I have just checked this value 60 is matching with 20 or not. This value 60 is matching with 40 or not. Value 60 is matching with 32 or not. We did all this checks and we have compared. But what we have decided, that is taking more time than the usual. Got it? It is taking more time than the usual. Since it's taking more time than the usual, what we have done, we have come to the binary search. Now, what we will do in the binary search, understand the algorithm. Well, what is the first step? Whatever value we want to search should be compared with the middle value. Middle value at first. So, in order to do this binary search, the most and foremost thing is arrays should be sorted. Arrays should be sorted first. Okay? Before performing a binary search,
bathroom don't close water on the bed.
Before doing a binary search, what is the condition is array should be sorted. So if you see this rule, I'll say minus 32, 20, I have to say 40. Okay. Now the array should be sorted in ascending order. This is the condition we have for binary search. Sorting doesn't take much time because we have a direct function. It will help you sort the data. Okay. Now what I have to do, I have to whatever value I want to search should be compared with the middle value at first. So when I compare this value with the middle, isn't it a match? Are we getting a match here? Yes or no? Check if that value is matched. If the value is present at the middle, then our search is completed. Clear? If the value is present in the middle, then our search is completed. Right? Now, in this case, the value is not matching, guys. Okay? In this case, the value is not matching. So what we need to do, what is the third step? If the value is not matching with the med, then what we need to do, we have to check the value 60 is present on the right hand side or left hand side. So if the value is not matching with the width, then we have two use cases. What is the use case one? If the target value is less than the med, then avoid the values on the right hand side. If the target value is greater than the med, then avoid the values on the left hand side. You got the point? Here, in the first comparison only, I'm checking if the value is found, great. If it is not found, now what is happening here? Now 60 is greater than 40, right? If 60 is greater than 40, I need not search the data on the left hand side. Okay, I need not search the data that is present before med. Now what will happen automatically? The starting position will not be this. The starting index position will be here. Clear? Is this clear? Any doubts so far?
Yeah.
Chiranjeevi, Shalu, Revati.
No, Rahul.
I mean,
Yeah.
is it clear or not clear? I'm asking that.
Yeah, it's
Yeah.
clear. It's clear.
Okay. Now, if everyone is clear, what we need to do next? Okay. Now we are checking the starting index position is this. Now what I have to do here? I'm checking whether this value 60 is matching with that. If it is matching, then it will returns the index position of the value. Clear? Is this clear, guys? Any doubts?
No doubt.
Okay. Once we have found which half of the data needs to be eliminated, then we check each and every data on the other side to find whether our value is present or not. So if you see here, I'm straight away eliminating half of the values in the array. Unlike linear search, I'm not comparing each and every value. I'm first checking which side my value is present, on which side my values are present. So after making that conscious decision, then what I will do, I will eliminate all the data. Okay, I'll eliminate one side of data. I will eliminate the data on the other half, and I will compare with whether my data is present or not in the other half. Clear? Is this clear?
Just one point, this mid value check will be only once in a list, in array list. Only once. Or if there is a long array list, then
No,
again and
only
again we
once.
can
Middle value will be checked once. Where is my middle value? It will be checked
once.
only once.
Okay.
Okay. That middle value doesn't get changed, right? Okay. Now, if everyone is clear, is everyone clear with the algorithm, how it is search is happening and all? Guys, is everyone clear with the algo understanding of it? This is this should be very clear. If you're not clear with this, then it will be a problem.
Yeah. So in short, we are just like dividing the entire data in two parts, right?
Yes. In short, we
Okay.
are dividing it into two. That is why we say this concept as divide and conquer.
Okay. Okay.
The internal algorithm that we are using here is called as a divide and conquer.
Mm-hmm. Makes sense. Okay.
So this is one of the algorithms. I would share this divide and conquer algorithm in more ways. If you are attending any SDET interview for a Google, the most commonly asked problem is the cobbler game problem. Till last 3-4 years, the commonly asked question in this interview was cobbler game problem. That was there for the past 10 years, and it's very difficult to solve. If you ask people will check in the estate or any developer profile, the commonly asked question is what about the cobbler's game problem. They'll ask you to solve that problem and tell me in how many ways the cobbler can steal. Clear?
Okay.
So this is what I have experienced in my interviews when I had the interview with all these guys. They really used to screw me big time. So with that experience, I'm telling you guys. Okay. I hope if everyone is clear, can we go for the next one?
Yeah.
The programmatical part.
Yeah.
Again, let me declare an array. Okay, let me declare an array. Got it? Int target is 21. Now public static void perform binary search. Okay. Now what are the attributes required? Int array, int target. Clear?
So we need another array to store the half, right?
No need, no need. Just hold on. I'm not storing any array, right? I'm just searching for the data. I'm not sorting here, right?
Okay.
Now, what is the first step? I have to sort the data in ascending order, no matter what. Okay. Now, int left equal to 0, int right equal to array dot length minus 1. That is what we have discussed right at the start. What is the left position? What is the right position? Okay. Int mid equal to, okay, int mid equal to 0. Now what I will do here, I will make a decision while, see, always the thing, what is the condition we need to check? Always the left index position should be less than equal to right, right? Always the left index position should be less than right index position. They cannot be equal, right, while comparing the data. Got it? They can also be equal, but as of now, are you able to understand this thing? So always the left index position should be less than equal to right index position. It cannot be more than that. So what is mid? I'm taking the mean average, left plus mid by left plus right by 2. That means I'm taking the average. Got it? Now, once I take the average, now, what I want to do, I want to check if A of mid double equal to target. Now, if A of mid double equal to target, then I will say element found at so and so mid position. Now, else if the array of middle, like whatever the value that I've got in the middle position, like in this case 60 40, if this is greater than the searched value, if this is greater than the targeted value, then what I have to do, right equal to mid minus 1. That means what? So what we have taken care here, I've set the value to be searched is 60. That means if the value is present on the right hand side, then the left index position should be mid plus 1. Got it? Then the left index position should be mid plus 1. Now, if the value is present in this other half, then the right position will be mid minus 1. Are you able to understand this point? Okay, let me draw this other scenario. Okay. Now this is my array, guys. Let me explain you this other half. What I'm trying to say, now I'll say value to be searched. Value to be searched. What is the value I want to search? Now I want to search the value 20. Now what is the middle position here? First I have to sort the data, right? That is the first and foremost thing. I have to sort the data. Okay. Okay. Now what I will do, now if I want to check values 20 or not. So as I've told you, this is the leftmost, this is the rightmost, and this is the mid one. Okay. Now what I want to do, I want to check whether this value is matching or not. Now this is not matching, but what we have understood, this 40 is greater than 20. That means the middle value is greater than the target value. So once this condition is satisfied, then this other half of the data won't be there. And what will be the right value? What will be the right? It will be, my right value will be present here. That means mid minus 1. Clear? Is this clear,
Yes.
guys?
Yeah.
Yeah.
Any doubts so far?
No
Guys,
doubt.
any doubts so far with this?
No doubt.
Okay. Okay. Once this value is clear for you, then what I will do now? Okay. Now this left is equal to right. Now what I have to do? I have to check whether this value 20 is matching with this or not. Now if this is matching, then I got my value. Then value found at so and so index position. Okay. This is the other half of the binary search. Else left equal to mid plus 1. When I say right equal to mid minus 1, that means what? My right position is present here. That means mid minus 1. When I say, if you go here, if I say my target value is greater than the middle value, then my left position obviously will be middle plus 1. Okay. So this is how we write the code. And we keep on checking whether the value is present at that position or not. Got it? Is this clear, guys? Any doubts so far?
Clear.
So if I keep on changing the position, again I have to check left plus mid is right equal to 2 or something like that. And let us see whether the value is found or not. Okay. Now if my element is found at middle position, then I'll break the loop. Okay. Okay, let me find whether the value 3 is present or not. Got it? Now it is saying that element is found at a first index position because here we are sorting the array. Got it? Here we are sorting the array. Now what I will do here, let me check for the value 21. Got it, everyone? Always remember, don't take this original array, sort the array and see what is the data. Clear? Any doubts so far, guys? All good?
Yeah, clear.
Well,
So this is the binary search algorithm. This is one of the most trickiest algorithms in search. There are more searching algorithms, but these are the most popularly used searching techniques in any arrays. And the same thing we can use it in the web tables. Like if you don't want to search the whole data, whatever data I get, I can store it in a form of an array and I can perform a binary search whether my data is there or not. Like suppose tomorrow in the interview, they'll be asking you like, I don't want to make you use of streams, but still I want you to search the data. Can you come up with an efficient algorithm? Yes, we can do it like this. Clear?
yeah.
Basically, you guys will be working in some banks or somewhere like that. And you're working in some big firms. Obviously, your role will be more on the data. See, not only in any development, yet, even in testing also, what we are testing here, whether the data is created properly, whether the data is processed properly. These are the primary things that we keep a look at it, right?
Yeah.
So ultimately, it's all about data. How you play around with the data, how you manipulate the data easily. That is what it matters. And that is what we need to follow. Clear?
Yeah.
Any doubts so far, guys?
No. I
Rahul,
just yeah.
Yeah, tell
Go
me.
ahead.
like mostly data science is connected with this.
Data science is a different ball game. There you need to use Azure, Databricks, and all the stuff. That is a different ball game. We are not even talking about data science. First of all, in a QA, what kind of data we get, we have to process it and understand, right? That is what I'm talking about. Okay. Data analysis is like more of a you analyze the data and you predict what will happen in the future with this data set. Got it?
Okay.
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 I hope everyone is clear with it so far.
Yes. So my question was like we can only use this binary search when we know the outcome, right? Like, but if they say like find the minimum, find the maximum, then we cannot use the binary search, right?
Sorry.
Like we can only use the binary search or linear search when we know the outcome. Like you have the target 21, right? So
See, if you don't know, see, now you
yeah,
put some target. If the target is not there, obviously it will return a blank value. For suppose if I put 100 now, if the data is
hmm,
not found, it will return empty.
yeah,
Got it?
yeah. That's what I'm saying. Like, but if we have to use like find the minimum value in the array, or the maximum value,
The search
we
purpose is
have
not
to
that.
put for loop, right?
Yeah, see, the purpose of search is not about finding the minimum and maximum value. Whatever target we have given, it is there or not. That's it.
Yeah, yeah, gotcha.
Finding the minimum and maximum, you can use a sorting technique and you can do it. So that is what the binary search algorithm that I have used in the arrays. Got it?
Yeah,
So what they are doing in the default method of Java, if the value is not present, it is saying like return the lowest value plus one, like that. Got it? Return the nearest lowest value plus one in the binary search algorithm that Java has written.
okay.
Okay. So like this also we can modify our code slightly. Now instead of void, I will say int. Okay. If that condition is not satisfied, then I'll say return as they told low plus one, left plus one. Got it? Like if the value is not present, whatever the leftmost value you got, na, what it is trying to say, I'm giving you the nearest value where I got with a negative symbol. When I say a negative symbol, that means the value is not found, but the nearest value that I can have is this at the left hand side. Clear?
Yeah,
And so it's saying -7. So when I say -7, what is happening here? So it is the nearest value that I have in the array is 52. Got it? What it is trying to say, the nearest value that I have in the array is -52. Clear? Any
yeah,
doubts so far?
no.
I hope if everyone is clear, can we break for the day? Because two algorithms, if you are okay, we can have a discussion. But I hope these two algorithms are okay for the today.
Yeah, yeah.
How about others?
Yes, yes,
So, thank you.
thank
So
Thank
you.
we'll
you.
try to catch up on a regular every Saturday. Okay.
Yeah.
Okay. Okay. Thank
Thank you.
Okay, guys. Next time we catch up, we discuss more on sorting and your doubts.
you. Okay. Thank you.
Thank you. Bye-bye.